Okay, now question number 14. In diagram 14, two equilateral triangles are drawn on sides of square PQRT. Given the area of PQRT is 64 cm squared. Okay, this is 64 cm squared, just the square. Okay? Calculate the perimeter in cm of the whole diagram. The perimeter of everything. So if the square of the square is 64 cm squared, then what is the length of its sides? Okay, what is the length of everything here of its sides? Okay, in fact everything is the same, right? All the edges of even the triangle, they are all the same side now, because the triangles are equilateral triangle. So 64, if you want to find the length of all the edges there, then is square root of 64, which is, guess what, 8 cm. Okay, we can check. If you are not so sure, we can go and check using our calculator. Square root 64 is 8. Alright, so everything is 8 here. Okay. So this 8 cm, 8 cm, 8 cm, 8 cm, 8 cm, 8 cm. How many edges are there? 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So the area, the perimeter is 6 times 8, which is 48. Okay, you are not sure? Use your good old calculator. 8 times 6, which is 48. There you go. Next question, number 15. In diagram 15, the area of triangle QTSR is 36 cm squared. Right, this 36 cm squared. Calculate the length in cm of QR. So QR, we need this length. Alright. Okay, what we know? We know that TS is 10 cm. Okay, and not TS, I mean TR is 10 cm. And TS is 6 cm. So what we can do, if we can find out the height of the triangle, or the side of the triangle SR, or the height of the triangle QTR. How do we use that? We can use Pythagoras theorem, which is square root of 10 squared minus 6 squared, which is 100 minus 36, which is square root of 64. 64. Let me just check it. 6 squared is 6 squared. 6 squared is what? 6 squared is 36, correct? So 100 minus 36 is 64, correct? And square root of 64 is 8. 8 cm. Okay, so that's the height of the triangle. So this is 8 cm. Okay, so the area of the triangle is 36. So QR, the formula of area of triangle is half, in this case QR, right? QR is the length that you want to find, times the height, which is half QR times height, which is 8. Okay, which is 36 squared, 36. Okay, we can cut this out. 4. Then QR is then 36 over 4, which is 9. Okay, the answer is 9 cm. Alright, let's move on. Okay, number 16. In diagram 16, PTR is a straight line. Calculate the area in cm squared rectangle PQRS. Okay, the whole diagram. PQRS. Okay, we want to find the area total area. So what we need to do, we need to find the individual triangle first, the area of individual triangles. Alright, so what do we know? Okay, we know the height of this triangle. This is a right triangle, right angle triangle, okay, of the, let me just label them as 1, 2, and 3, okay. So what is area of triangle 1? Triangle 1 is half times 2 times 4, which is 4. Triangle 2, which is half times 4 times 3, which is 6. And then triangle 3. Okay, triangle 3, we need to do a bit more homework because we do not know the length of PQ. Okay, but we know the hypotenuse. Hypotenuse is 5 cm. The hypotenuse of the triangle is 5 cm. That one, alright? So what is PQ? I put it here then. PQ is a square root of, we use Pythagoras theorem, 5 squared minus 3 squared. Okay, then it's 25 minus 9, which is 16. Square root of 16, which is 4 cm. Okay, to actually, we can do Pythagoras theorem on this one, but it is good practice if you could, memorize some of the magic triangles. One, for example, one that we probably want to memorize is that if you have two sides, 3 and 4, then the hypotenuse is 5. Okay, this normally come out in your examination regularly. So if you happen to see any of these triangle, right angle triangle with 3, 4, then you know hypotenuse is 5. If you are given 5 hypotenuse and the other side is 3, then the other side is 4. So memorize this triangle. It's very, very useful. It will make your job even faster. So what is the area of the triangle number 3? Half times 4 times 3, which is 6. Okay, then the total area of the rectangle PQRS, okay, is 16. Then 6 plus 6 plus 4, 16. So it is D. Right. Move on to the next question. Number 17. Diagram 17 shows a net of geometric solid. Okay. Name the geometric solid. Okay, this question there is no calculation, but we need to use some imaginations. So you can see here, you have the square. Let me use, you have a square there. I think that square must be a base. And you have a triangle by the side. Okay. Let me just draw something. If I take out this triangle, okay, I put it at this side, you can transfer it there. And if I take out this triangle and you put it there, so what do you think you can get? You fold up those triangles up so that the tip of this triangle, of the triangle over there, meet each other, okay, all meet. So what do you get? Yes, you get pyramid. You get a pyramid, definitely. So this type of question, there is no calculation, but you need a good imagination. You need to see how that that plan, fold up to each other, fold up, and what geometric solid that you will form. Let's move on to number 18. In diagram 18, QRS is straight line. QS is equal to SU. QS is same as SU. Where is SU? Okay, alright. SU is the hypotenuse line. QS is the same as SU. Calculate the length CCM of ST. So we need to find this. ST is the length that we need to find. So how do we do that? I think the key is, of course, to find the hypotenuse of the triangle STU. Okay. Once we get the hypotenuse, because TU is known, 12 cm, we can find ST. So how do you want to find hypotenuse? I think the clue must be in the second triangle here. Since we know RS is 3 cm, we just find the hypotenuse of this triangle, the PQR triangle. So here again, we have a triangle with 6, 8. Remember or not, the previous question I did mention, if you find a triangle of this nature, if this side is 3 and this 4, this must be 5. Okay, and you compare with this triangle, which is slightly bigger, twice as big. Okay, twice as big. This side is 6, okay, which corresponds to this 6, and this side is 8, which is correspond to this side. What do you think is the hypotenuse? If you can see, okay, 6 is 3 times 2, and 8 is 4 times 2. So what do you think is the hypotenuse? Of course, yeah, 5 times 2, which is 2. So I need not do Pythagoras theorem here. I know for a fact that if I see that triangle, then I immediately know the hypotenuse is 10. But you need to know, you need to be familiarized with the popular triangle as I mentioned. So you know then QS is 13. So hypotenuse that we are looking for here is 13 cm. Okay, this is actually another popular triangle being used in examination. This triangle, okay. In this case, we have 13 at the hypotenuse. This is a right angle triangle, and this is 12. And this is actually something you need to remember. Let's go and figure out what that is. Okay, by using Pythagoras theorem first. 13 squared minus 12 squared. Okay, we can use calculator right straight away. How? Okay, turn it on. Put square root. Put bracket, and then 13 squared minus 12 squared, close bracket, you'll get the answer, which is 5. Okay, so this is another popular triangle that is very useful if you memorize. So RS or ST is 5 cm, so the answer is A. Number 19. Diagram 19 shows a triangle drawn on a Cartesian plane. Okay, triangle drawn on a Cartesian plane with side of 1 unit. Which of the triangle A, B, C, and D is enlargement of triangle P? So triangle P is this one. It has side of okay, we need to find enlargement. I think it's pretty obvious, right? You know this is isoscale triangle, and there is only one isoscale triangle from the rest, A, B, C, and D. Which one? Which is C, right? So this is the only isoscale with right angle triangle, which is this one. Yeah, and if you take a look at this diagonal length, right? Diagonal length, right? This is 1 unit diagonal, and this is 2 unit diagonal. 2 unit diagonal, and this is 1, this is 1, and what about this? This is 2 unit, and this is 4 unit. So you know this is enlargement by a scale 2. So the answer is C. Move on to number 20. We can try to answer a problem as quickly as possible. If you get stuck, just leave it out for a while and do the easy one first, and then you come back to it later. Number 20, diagram 20 shows a semicircle with center O. Find the value of x. Okay, value of x. Alright, let's take a look at this. You have a semicircle. Alright, and that's the line coming from the center. Then we know this is 84. And then what about that angle? Do you know what that is? That is actually half of 84. Okay, if you don't remember this, then you need to open up the book. So probably in your textbook. Okay, this by the way is 42 degree, right? By the way, if you're in the book, then you probably see something like this: center O, with an angle coming from the center of the circle, and then at any point of the like for example this one, okay, or this is half of that. Okay, if this is 2x, then this is x. So if I put another angle coming from here, this is also still x, which is not x, that is alpha, right? X, right? Which is half of the angle here. So here this is 42 degree. So how can you find x then? X and 2x, and this because this is 42, then and this is 84, then you can find that angle. What is that angle? 180 minus 84, which is 96 degree. Okay, 96 plus 84 is 180. And then what about 3x? 3x is, okay, because that forms a triangle of angle 42, 96, and then 3x. So 3x is 180 minus 42 minus 96 degree. Use your calculator. 180. Why 180? Because total of angles in a triangle is 180. Minus 42 minus 96, which is 42. So 3x is 42. What is x? X is 42 divided by 3. X, you have 42 divided by 3, which is 14. The answer is A. Move on. Number 21. In diagram 21, SR is an arc of a circle with center O. Okay, and that ROS is a right angle. Given POS and RQO are straight lines, and the triangle POQ is 15 cm squared. POQ is 15 cm squared. Okay, this is 15 cm squared. Calculate the length in cm of arc RS. Okay, we know this is RQ is 10, so we need to find the radius. If we want to find the arc, then we need to find the radius, OS or OR, the same, right? OS and OR the same length. But how do we want to do that? We need to find QO. We need to find QO first, okay? We need to find this first. Then we add 4 to it, then we can get the radius. When we get the radius, we can find the arc length RS. Okay, SR or RS, and we use pi as 22/7. So take a look at that triangle. This is a right angle triangle with 3 cm. And what is the formula of the area of triangle? Half times base times height, which is 15, right? So base is known, which is 3. Half times 3 times height is OQ is 15. So OQ is 15 times 2 divided by 3, which is 6. Okay, 3 and 5, this is 5, right? It's 5, 10, not 6, 10. Alright, so you get 10 cm. So the radius of the circle is 10 plus 4, which is 14 cm. Okay, so now we want to find arc length SR. So arc SR is a quarter of the circumference, right? So what is the formula of circumference? 2 pi r. A quarter, not let me just get this one corrected. Not 1/2, but 1/4, a quarter. Okay. 2 pi r. This is the formula of the circumference of a circle. Alright then, and so that is equal 1/4 times 2 pi r to, let's put square bracket, 22/7. R is 14. Okay, we can cut out, let's use red. This is 11 and this is 2. Okay, so the answer is 22. 22 cm. Well, let me check. 4 and 2 and 22. Yeah, cut out. We get 7. 11, 7, 14. Cut out become 2. 22 cm. Yes, that's correct. 31 is B. Alright. Number 22. Diagram 22 shows 4 quadrants and a rectangle KLMN. KLMN. Okay, diagram 22 shows 4 quadrants. 4 quadrants and rectangle KLMN. KLMN is a rectangle. Okay. 2 quadrant with center K. And the other 2 quadrant with center M. Okay. Pretty good question, huh? Calculate the area in cm squared of the whole diagram. Alright. Whole diagram. It's not that difficult, right? First, we know that the radius of the circle is 4. So that is 4. Okay. Then we know that this is also 4 cm. This is 4 cm. And the whole thing here is 8 cm. Okay. And there are 4 quadrants of a circle, which means that if you want to find the area of the 4 quadrants, then it is essentially equivalent to one whole circle, right, with radius 4. Okay, because you've got all that 4 quadrants divided here, right, divided here, and made up, it's been being divided and put somewhere else. So if you put it back, put all the quadrant, right, quadrant 1, 2, 3 and 4 together, you put it back together, you get one whole complete circle. So what is the area of that one whole complete circle? Then it's pi r squared. Okay, which is equal to pi, I believe. Yeah, we will leave the answer as pi. We are not going to resolve the value of pi there, and that is equal to pi area circle, area of a circle. Okay, pi r is 4 squared, which is 4 squared is 16, so 16 pi. And what about the rectangle here? Rectangle here is 8 times 4, which is 32 cm squared. So pretty easy. So the whole diagram, the area of the whole diagram is equal to 32 plus 16 pi cm squared. So do we have that answer? 32 plus 16 pi. 16 pi. Yeah, we have D. Okay, I did not notice there's D. The 16 pi plus 32 is the same thing. Yep. Okay, D is the answer. Number 23. Diagram 23 shows 2 circles with center O. JKLM N is a straight line, and JK is equal to K. JK is equal to KM. Okay. Alright, so if you can see, right, this length over here, I just put down broken line as a reference. as a reference. Okay, all these three lengths are the same. They are all the same length. Alright, JK is equal to KM, and thus it must be equal to MN then. Okay, they are the same. They are the two circles with same origin, of the same, center O. So what's the equation? Find the length. Find the length is MPL. Okay, we need to find PL. PL is this one. Okay, the line in blue. Let's take a moment thinking about this. Right. Okay, one information that is not being described but is shown in the diagram is that JK is 24. So everything here is 24. So what information can you use there? That means we can take out, okay, the triangle of our interest, which is O, L, and K. This is a right angle triangle. While KM is 24, right? KM is 24, so KL is then half of 24, which is 12 cm, okay? And OL is 5, so you know that OK is 13. Remember that I have described another popular triangle in Pythagoras theorem is 5, 12, and 13. Remember that. So I do not want to repeat the Pythagoras calculation there, because I know that OL is 5 and KL is 12, so OK must be 13. Okay, so if OK is 13, then PO is also 13. Then PL is then 13 plus 5, which is 18. So that's the answer. PL is 18. Let's see, we have 18 in there. Yes, we have. That is C. Number 24. Diagram 24 shows a circle KLMN. Circle KLMN with center O, J and K is a straight line. J and K straight line. Alright. Find the value of Y. Where is Y? Oh, okay. There's a tiny Y there. Alright. So we want to find Y. Again, let's go and spend some time. Okay. You see there 100 degree in the middle. That means this angle here is half of that, which is 50 degree. Alright, then we know this is 80. Then that angle is also 80. It has to be the same as that one. Okay, so let me refresh. If you have a circle, alright, with 4 side polygons inside here, that angle is the same as this one. Okay, so since that angle is 80, then Y is 80 minus 50, which is 30. The answer is A. Alright, let's move on. Given 3 minus 2x is less than minus 5, find the value of x. Okay. Now let's do this. Inequality. 3 minus 2x less than minus 5. Okay. And then minus 2x is less than minus 5 minus 3. Then it's minus 2x is less than minus 8. So now if I want to get rid of the minus, then I put positive value to x is greater than 8 now. Okay, we have to switch side. Whenever we switch the sign, then we need to switch, it become greater than. Then x is then greater than 8 over 2, which is then x is greater than 4. Let's take a look. Then it is exclusive. Okay, it does not include 4. It does not equal 4, but greater than 4. So it's B. So the video is already close to half an hour, so I'll stop here. I will continue question number 26 in the next video. See you.